So that is all from Armando over at Arty, and we're now swiftly moving forward to David Smith, who is CEO of the Croquet Corporation. David has a wonderful career in AR and VR with over 35 years of his life invested to the industry. He invented Portals, wrote the first real-time 3D adventure shooter, the first real-time 3D design tool, and is now the CEO of Croquet Corporation. So, needless to say, the floor is David's.
Hi, I'm David Smith, and I'm going to be talking about the augmented conversation. And I'm going to do it in a little bit different way than normally. Actually, would actually be normally a full audience participation segment, but we can't do that today. So I'm going to stand in for you in a sense. And what you see is not just an augmented conversation application, but my team over to the side. And some of them will actually be interacting with us as we do this. To give you an idea of what I mean, everything you see is going to be multi-user. And to start, it's even our presentation is multi-user. And anything I do here to this object that you see, which is obviously my demo, you're going to see it in exactly the same way if you're one of the participants. So all my team sees exactly what I'm doing. So let me give you an idea of what I mean by augmented conversation. There's three key features. First is a discussion with a group of users that's extraordinarily enhanced with what you have available with a computer today. It allows you to generate a shared experience, but the computer is kind of the orchestrator of that experience. Two is the computer AI is a full participant. In other words, as I talk to you and you're talking to me, the computer's listening, watching, and generating simulations and information as we do that. In other words, what we're really after is a way to talk about complex ideas as naturally as we talk about the weather today. The third thing is there has to be a guarantee of shared truth. In other words, what you see has to be exactly what I see, and anything I do to affect that shared simulation has to be accurately shared. Otherwise, you don't trust that. In other words, if you're seeing something and I'm seeing something different, and we're making decisions based upon that, I feel like I can't be guaranteed that I understand what it is you're saying. So this absolute shared capability, including simulations, is essential. So in the very near future, these virtual objects that we see with augmented reality are gonna populate our world. In fact, there's gonna be far more digital virtual objects in our worlds than physical. And what's essential is that what you see is exactly what I see, and what I see is as you do something, it's exactly the same. So I'm going to talk about Croquet. Croquet is a platform that enables that. It's a perfectly synchronized platform that ensures that what I talked about earlier, what you see is exactly what I see. And as you do something, I see it as you do it. And what's really wonderful about Croquet is you're able to do that without having to communicate that really complex state between the peers. I'm going to describe a little bit about how that works in a second. This is the team. We invented Croquet. And I sometimes the missing internet protocol. And I think you'll understand why as we go along. This team was working together in the 2000s. Starting from the right is Andreas Raab, who's one of the best programmers I've ever had the honor to work with. He was also one of the main people behind Squeak, the small talk programming language, and Tweak. David Reeds, actually, we wouldn't be having this conversation without him. One thing he did was invented the UDP protocol, but he was also instrumental in designing TCP/IP, which is basically how we're shipping bits around right now. He's also responsible for creating a thing called Reed's Law, which describes how the internet scales. Alan Kay, you're probably familiar with. Alan was the father of the personal computer. He's the person who created the system you're looking at right now in a lot of ways. Among other things, he invented overlapping windows. He invented object-oriented programming, but most importantly, he invented this vision of what computing could be and should be with a system called the Dynabook that was created. They created what they call the interim Dynabook at Xerox PARC, and that's what Steve Jobs and Bill Gates saw, and were able to then create the Macintosh, Windows, and even the iPhone. And then I'm over to the side. I was the chief architect of Croquet, and my background is I created the first real-time 3D computer adventure game, the first real-time 3D design tool, and I've been working on the Croquet project for quite a few years. How Croquet works is very different from traditional platforms, traditional client-server platforms. With a traditional server, what happens is it does the computation for you, and then it sends all the fix-ups to the views, what you see on your screen. So a user interacts with that view, sends up to the server does all this computation, and says, oh, this is what you need to know. And so there's a pretty high bandwidth communication that's required, and also a lot of latency because the server is doing a lot of computation. On Croquet, on the other hand, we actually have a very, very lightweight server, which they even call serverless today. It has no state. All the state is with the users. It's called a model view. The model is actually a virtual computer that runs bit identical with all the other participants. So everything you're going to see here, and even in fact what you're seeing right now, is running a bit identical computer on all the platforms that I'm going to be showing you. So Croquet is actually, we think is the best way to do what we call live collaboration. Classic systems are, if you've actually built multi-user systems, are hard to deploy, they're expensive, really lead to bad user experiences because they have a lot of latency and are really complex to build on top of. Croquet is a lot cheaper, primarily because it's got very, very low bandwidth and there's no server overhead. It's very, very fast. And this is one of the things that you absolutely have to have when you're looking at 5G deployment. Our bandwidth is a tiny, tiny fraction of what other people use. Again, because we're not sending all the fix-ups. We're just sending, hey, this is the message that somebody else sent, and this is the update. The system's really easy to deploy because it's all client side. You don't have to worry about the typical client server problem of programming the two and then debugging the interrelationship. And of course, it's fully encrypted all the way. And really, we've built a system for 5G deployment, particularly with AR as our target. So I'm going to demonstrate a couple of applications here. And one of the neat things about this is you'll be able to try them at home. I already showed you that my presentation's actually shared. And now I'm going to switch over and start showing this. Now, this is a simple little application. This is called Pix. And what's neat about Croquet is we try to make it totally friction-free between applications. So this is something you can actually try. What I'm going to do is grab a photo, and then I have my app running. What's really cool is I can now take a picture, and I'm going to literally take a photo. I'm going to back up so you can see my full screen here, and I'm going to use that. And what you'll see in just a second is that's my desktop. Brian can do the same. He'll be actually adding his little desktop. But the main point is we're trying to break down these barriers between devices. Right now, we're talking about this. Everything you see works in mobile. And that's a really essential aspect. It's a first step towards what we envision with an augmented conversation. So next thing I'm going to show you is a little game that we built inside of our system. And this one we call Pix. And what's neat is Brian and I can interact with it. Both of us can engage. What I'm going to do is grab hold of another one just so I can show you the two. And both of these work seamlessly. So you see me putting these little dots, these little voxels in the world, and everything is perfectly synced. And Brian's actually doing the same. And maybe I'll switch colors here. And but basically, everything I'm doing is perfectly synchronized with him. I can, and just to prove it, it's all live. I can move around. I can even spin this version. So like I said, what's happening is we're running a shared virtual computer underneath, so that the computations are a bit identical, even though the images don't have to align. And that's really important, because what happens is when we're collaborating in augmented reality, one of us is going to be on one side of an object, one is on the other. So it's not like a shared screen. It literally is a shared object that interacts with us dynamically as we do that interaction. All right, so next is a little drawing app. And again, what I'm going to do is capture that. You can do the same. Literally grab your camera, and I'm going to grab that drawing application. And what you'll see, if you see that, as I draw here on my screen, you'll see I'm drawing there. And Brian's drawing it at exactly the same time. So you see it's basically a completely live shared experience. And I think it's really important to understand too, I'm having these applications jump from one user to another, from one device to another, absolutely seamlessly. So the last thing I want to do is what we call bounce. And this one is actually a full shared simulation. I'm going to put another bounce app right next to this. And what you should see, by the way, almost no communication. We're running about 7.5 kilobytes per second between these two applications. And we see Brian moving objects around. But more importantly, look at the synchronization of the two systems. Look at the little balls that are bouncing. And remember, there's no communication. What's happening is we have a bit identical virtual machine on all of these devices, on Brian's system, on my system, on everybody who's participating right now, even on my computer behind me. And what you're seeing is a computation that's occurring a bit identical on all those devices. So we know what's going to happen with the simulation. So we don't have to send all that update. We don't have to send all that additional information, but we're still able to engage with it directly. So what you're seeing is what we believe is the absolute essential next step of communication and collaboration, using computer as a centerpiece of that. Albert Einstein said this is where I finally found who actually made this quote: "We cannot solve our problems with the same thinking we used when we created them." And the other thing is, Doug Engelbart said that we have to solve our problems collaboratively, or we're doomed. We see it's essential to build platforms that allow broadband communication. In other words, being able to explain things and share things in a far broader band way than we can do even face-to-face. Augmented reality is first and foremost communication platform, a collaboration platform. And our goal is to ensure that it is powerful and simple. And that's why Croquet exists. And we're pretty excited to be able to finally make this available to anyone. If you go to croquet.io, you can get access to the SDK today. And every bit of this demo is going to be available to you, including the application that contains all the other demos. So thank you very much. This has been fun, and I look forward to hearing from you guys. Thanks.
Hey, David, thank you very much. I really appreciate it. And I guess so do all the attendees. So really appreciate your time today, and thanks for joining us for a Q&A. I guess kind of initial question really, and one interesting for myself really, and where is kind of your primary, I suppose, adoption for the technology at this moment in time, and where do you see that adoption happening in the next sort of 5 years, potentially further?
Yeah, well, first of all, I want to apologize for the slow update. This app's actually run at 60 hertz when we're not going through Zoom.
But no problem.
Yeah, but the one thing that we're after and we see as crucially important is that virtual objects in augmented reality have to look and act and respond in the same way that physical objects do. That means that the latency that we can engage with those things, that has to be extraordinarily low. But the more important thing is when we're using these virtual objects to collaborate, you have to see what I do is exactly at the same time I do it. In other words, if I pick up an object in the physical world, you see that happening because it's happening at the speed of light. What happens when we're dealing with virtual objects to make those feel and act and totally engaging like the physical, they have to have that instant latency. That means you can't really compute in the cloud. You have to compute locally. And the other thing is you have to be able to still stay synchronized. And that's the key element of what we're trying to accomplish. Make it so that the idea of bit identical and simultaneous computing is happening as we engage with those objects.
So I guess in that regard, that you would consider the adoption of the technology limitless.
Yeah, actually, I think of AR primarily as a communication technology. What's going to happen is you and I are going to have conversations, and that conversation with an AI is going to, basically create those objects we're talking about. As we talk about them, we'll be able to interact with them as if they're real. So that's why we see this as so important. It's like the bandwidth between humans is going to go to infinity shortly once AR is good enough.
Sure. Makes perfect sense. Okay. And I guess a very interesting question for myself again personally, what's been your biggest challenge in creating the technology? I guess effectively getting the latency low would be the obvious answer, right? But I guess there's a bigger complex description to the matter.
Yeah. We had some ideas about how to do it a number of years ago, and it proved to be a lot more complex than we thought. Although it turns out that the actual solution was quite simple, but the path to get there was pretty excruciating. The simplicity of the thing, where basically this reflector serverless system. It doesn't have state is basically when you have shared virtual machines. That's actually not terribly hard. Making sure it's all perfectly synced, and when a new user joins, they get exactly that same state. That was hard, but it's sort of looking back is like I can't really say it's not hard anymore because it just works.
Sure. Makes sense. And I guess kind of coming back a little bit earlier in your career and actually getting to the point of, really driving the Croquet Corporation forward. What was the inspiration behind the idea?
It actually goes back 50 years to Doug Engelbart, where he demonstrated for the first time a lot of technologies that we take for granted today, the mouse, hypertext. But one of the things he had in mind and that he demonstrated we still haven't been able to do was true collaboration with computers, using computers as a communication platform. In his day, everybody ran on the same computer, so that's how he was able to get away with that. Once we went to the personal computer via Xerox PARC and then Apple and Microsoft, that collaborative part got lost, partially because it was difficult, and partially because there were so many other rich things that could be done. But it was really clear as we move forward, and looking at today, for example, collaboration is definitely moving to the center of our universe, given just the situation we're living through. But that's not going to go away. If anything, the demand for really high quality collaboration is going to go up, ultimately with augmented reality being probably the biggest use case.
Sure. Okay. Very interesting. And to be honest with you, I wish I had more time to dig deeper. I'm obviously on a very tight 5-minute schedule between each speaker. So totally apologize that I have to cut it off there. But honestly, again, it's been nothing but a pleasure to have you here. Look very forward to watching the company grow and the limitless potential behind it. You're onto something very special. So best of luck. And I'm sure we'll speak soon.
Thank you. All right.
Take care.
Take care.
Bye. Bye-bye.